Hello, my dear boys. Hope all of you are well by the grace of Almighty. Good morning, everyone, and welcome all of you to my online physics class. And we are starting chapter 10. The name of this chapter is Static Electricity, and we are solving some creative question on this chapter. Okay, so today we will also try to solve another creative question from this chapter. So, my dear boys, first let's see the today's creative question. So, my dear boys, this is our today's sample creative question. Here, the stem is two objects of mass 10 kg and 4 kg are kept at 80 centimeter distance in vacuum place. Okay. The two objects attract each other due to gravitational force. Okay, so my dear boys, this is the stem of our today's creative question. Now the questions are: question A, what is called capacitor? Okay. Question B, what do you mean by Coulomb's constant? Explain. Okay. And question C, how much charge should be stored in the both object so that gravitational force become zero? Okay. And question D is, do you think gravitational intensity will be zero at the midpoint of the two objects? Explain mathematically. So, this creative question is also related with the gravitation. Okay, so this question is not only in static electricity, it is also combined with gravitation. Okay, so my dear boys, let's start the solution of this question. So my dear boys, our question A is, what is called capacitor? Okay, so the answer is the capability of storing energy as electric charge is called capacitor. Okay, I am repeating it again. The capability of storing energy as electric charge is called capacitor. My dear boys, our question B is, what do you mean by Coulomb's constant? Explain. The explanation is, if the force of attraction or repulsion between two charges Q1 and Q2, which are at a distance d from one another, is F, then according to Coulomb's law, we can write F is proportional to Q1 Q2 by d square. Now we can write F equal to K into Q1 Q2 by d square. Here K is our Coulomb constant. Okay, so its value in vacuum is 9 into 10 to the power 9 Newton meter square per Coulomb square. It is called Coulomb constant. If two charges and two charges plus 1 coulomb and minus 1 coulomb are at a distance 1 meter from one another, then the force of attraction between them is 9 into 10 to the power 9. So, this is our explanation of question B. My dear boys, now we will try to solve question number C. Here the question is, how much charge should be stored in the both object so that gravitational force become 0. Okay, so here from the stem we have given that two objects of mass m1 equal to 10 kg and m2 equal to 4 kg, and the distance between the two mass is d equal to 80 centimeter equal to 0.8 meter. Okay, so my dear boys, firstly we will determine the gravitational force, which is also the force between the two mass will be mass. Okay, then this force, using this force we can measurement or we can determine the charge stored for nullify the gravitational attraction force. Okay, so according to the gravitational force we know that F equal to G m1 m2 divided by d square. Okay, here capital G is the gravitational constant. The value of this gravitational constant is 6.673 into 10 to the power minus 11 Newton meter square per kg square. Okay, so putting the value of these parameters and calculating, we get the gravitational force equal to 4.1706 into 10 to the power minus 9 Newton. Okay, so let q amount of charge is stored in both of them or both of the object. Okay, so here F equal to k into q, same charge. Okay, so we can write q into q divided by d square. Okay, here we assume that q amount of charge is stored in both of them, so we can write q into q. Okay, here k is the Coulomb constant and the value of this Coulomb constant is 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay, so putting the value of this parameter here, the force will be the gravitational force. Okay, so putting the value of this parameter and after calculating we get the value of charge is q equal to plus minus 5.44 into 10 to the power minus 10 Coulomb. So we can see that an amount of 5.44 into 10 to the power minus 10 Coulomb positive or negative charge on both will nullify the gravitational attraction force. So this is the solution for question number C. My dear boys, now we will try to solve question number D. Okay, here the question is, do you think gravitational intensity will be 0 at the midpoint of the two objects? Explain mathematically. Okay. So, here this is our required figure. You also should draw this figure. Okay. Here this is 10 kg mass object, and this object is, the object of this mass is 4 kg. Okay. Here let a unit mass is placed at point P at a distance x from 10 kg mass. Okay. The point P is placed from x distance from 10 kg mass, and let at point P the gravitational intensity is 0. Okay. Let at point P the gravitational intensity is 0. So we can write E1 equal to E2. Here this is our formula for gravitational intensity. Okay. So we can write G into m1 by x square from intensity at 10 kg mass. Okay. And Z equal to m2 divided by 0.8 minus x whole square from intensity 4 kg mass. Okay. So this two intensity is 0 because we assume that at point P the gravitational intensity is 0. Okay. So putting the value, we get 10 by x square equal to 4 by 0.8 minus x whole square. So after calculating, we get the value of x is 0.49 meter. Okay, the value of x is 0.49 meter. It means that the gravitational intensity is 0 at point P, which is 0.49 meter far from 10 kg mass. Okay. But our question is, do you think gravitational intensity will be 0 at midpoint of two charges? The distance between these two objects is 0.8 meters, so the midpoint is 0.4 meters. The midpoint between two mass is 0.4 meter, but our gravitational intensity will be 0 at P, which is far from 0. Which is the distance of point P is 0.49 from 10 kg mass. Okay. So 0.49 is equal to not 0.4 meter. Okay. So we can say that therefore intensity is not 0 at the midpoint. Okay. Intensity is 0 at 0.49 meter from 10 kg mass. Okay. So my dear boys, this is all for today. In our next lecture, we will try to solve another creative question. So until then, thank you boys.